Hey physics class, so I'm going to be working out the solution for this, the final and most complex circuit. Now, as part of the problem, I said that we'd put on a 12-volt battery, so I'll just go ahead and do that. Okay, now the circuit is complete. Okay, well, in order to simplify this, it's going to help to break down things that are clearly in series or in parallel. This is all very confusing. There is a more kind of left to right picture that I put in the classroom, but I'm going to go ahead and just break things down in this view. So these two are in a loop kind of by themselves. They're in series, which means resistors 7 and 8 together make 100. 250s in series make 100. So resistors 7 and 8, that's 100. Now, looking at that this way, this is 1 followed by 2 in parallel, followed by 1, and this is a series loop here. So I'm going to want to find these two in parallel. The equivalent resistance of 6, 7, and 8 in parallel will add up like this. So we just need to work that out. This would be 1 over 50. That's 1 over 100. Common denominator, there's 1 over 50, or 2 over 100. And so that means it's 3 over 100. Well, if that's 1 over that resistance, then that means that it's 100 over 3. Well, 100 over 3 would just be 33.33, so we'll go with that. Now, these three are in series. 10 plus 33 plus 33 plus 50 would be 93.33. 60 plus, yep, so 93.33. So to replace these, 93.33. This is now replacing resistors 4 through 8. That's that's a lot. Now, as far as these go, these are all in parallel. They're all in parallel. There's no series left because you can either go through this or that or that or that. They're all in parallel. And so that means that the sum total of the resistance of this whole circuit is just going to be equal to the sum of all the reciprocals and so I'm going to have to do some math here. So let's see. 1 over 93.33 is not a lot, but I do plus a tenth, plus a tenth, plus a tenth. So I'm going to just do plus 0.3 because that's plus 3/10. And I've got 0.3107. So if I did 1 divided by 0.3107, the total resistance is only 3.219 ohms. That's all. That is not a lot. Okay, so if that's the sum total of the resistance, we're going to need to use that to find some currents and some voltages across individual resistors. So I'm going to have to restore the entire circuit so we can look at every resistor in its own context. So let's see, here we had resistor 4, which was 10, and that went down here. There's resistor 6, which is 50. Resistor 5 is also 50. And there were 2 here. Resistor 7 and resistor 8, both 50s. Okay, so we've got the sum total resistance for the circuit, but if we're going to find how much voltage and how much current are through each of these resistors, we need to look at these all in various parts. So, first thing we want to see is that this group here is like a single resistor. We had combined them all together, resistors 4, 5, 6, 7, 8. And that is in parallel with all those, which means 12 volts is across here, 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 and that whole thing. So we can finish resistors 1, 2, and 3 pretty quickly. There's not much to them. For resistor 1, which is, of course, 10 ohms, the voltage across resistor 1 is 12. Sorry, I tried to make that clear and I made it worse. It's 12. The current through resistor 1 is just 12 over 10, or 1.2 amps. The power consumed by resistor 1 is going to be 1.2 times 12, which is 14.4 watts. That's a W, but it looks like an N. Let me try one more time. So those are all the values for resistor 1. Resistor 2 and 3 are both going to be the same. Same voltage, same resistance. So this would be true for resistor 1, resistor 2, and resistor 3. What about resistors 4, 5, 6, 7, and 8? Well, in order to get that, we're going to need to go back and be reminded of what the resistance of this is. We know that there will be 12 volts across it, but we don't know what the resistance is, and so we don't know what the current is. So we need to remember what is the resistance of this whole group. And if memory serves, it was 93.33. 93.33. So if this whole thing has a resistance of 93.33, then I could say that there are 12 volts across it. And if there is a resistance of 93.33, then the current through here is going to be 12 divided by 93.33. 12 divided by 93.33 is 0.1286. 0.1286. It's 0.1286. Now, because this is a group in series, granted that's in parallel, but this is in series. 4 is in series with 5. That means they both have this current through them. So I could say, for example, here I'll do a different color just to keep them separate. Resistor 4, which has a a resistance of 10 ohms itself, has a voltage across it of, well, not 12 volts. If the current through resistor 4 is 0.1286, and the resistance is 10. Looks like I've messed up the 10. If the resistance is 10, then by Ohm's law, voltage is equal to current times resistance. So I can just multiply this by 10 and get 1.286. 1.286 volts. As I mentioned, the current was worked out to be 0.1286. And here the power would be the product of these two. So just go ahead and multiply 0.1286 times 1.286. And I've got 0.1654. And that would be watts. Okay, so we've got resistor 4 there. Resistor 5 will have the same current, but a different voltage because it's a different resistance. So let me get rid of that. I think I can start fitting some stuff in that space. Resistor 5 has a resistance of 50 ohms. Now, I'll get the voltage in just a second. I know the current is equal to 0.1286, and just to remind you, I know what that current is because I know the total resistance of this group here, and that means everything in series has the same current. So 0.1286 is the current. Multiply this by 50, and that'll give you the voltage. 50 times 0.1286, 6.43. So there are 6.43 volts across resistor 5, and the power will just be the product of those two numbers, 6.43 times 0.1286, that's 0.8269. Okay, now I can take advantage of a little shortcut here now. Knowing that the current is 0.1286, we were able to get those voltages. And I also know that there's 12 volts across this whole thing. I've accounted for 1.286 of them. I've accounted for 6.43 of them. And because this is in parallel, the same voltage will be on both branches. So if I were to add up 6.43 and 1.286, I would get 7.716. Now if there are 12 volts in it, that's only 4.284 volts unaccounted for, and they all belong here. 4.284 volts. So, since this is the only part that we still have to figure out, I'm just going to get rid of all this so I have the space. And I've got 4.284 volts across that. Now, if there are 4.284 volts on 50 ohms, according to Ohm's law, voltage equals current times resistance. So if I divide V by R, I should get I. So let's just do resistor 6 up here having 50 ohms. The current should be V divided by R, so 4.284 divided by 50. It's 0.8568. Oh, silly, I forgot to write the voltage. I was writing voltage first before, so I'll write it again. 0.8568. And the power, that would be the product of the current and the voltage. So if I multiply that by 4.284, There we go. So apologies if there's any confusion over that negative sign. That was just a little shortcut I did. I did something minus 12 to get the voltage here, and I've just been ignoring the negative sign ever since. So sorry if that's caused anyone any confusion. Oh, I should probably put units on here. That's volts, amps, and watts. Now, resistors 7 and 8 also have to share 4.284 volts. Really, it's a stroke of luck that they're the same resistance, because that means they each take exactly half of that voltage. I don't even need a calculator to divide that in half. They're all even numbers. So resistors 7 and 8 will be identical, and I can just record their numbers here. I haven't used red yet, so I'm going to go ahead and use red. So the resistance is 50 ohms. The voltage is going to be half of 4.284. That would be 2.142. As for the current, well, I can get it by dividing V by R. V divided by R would be 2.142 divided by 50. So there's the current, 0.04284 amps. And the power is going to be the product of this and that. So just multiply this by 2.142, and that's 0.09176 watts. All right, and this is going to be true for both resistors 7 and 8. So there you have it. Resistors 1, 2, 3, resistor 4, resistor 5, resistor 6, resistor 7, and 8. Don't worry, this was much more complicated than any circuit I'm going to give you tomorrow, and it won't take you 17.5 minutes like it took me.